Hello everyone. In our previous video, we have learned about the zeros of the polynomial, how to find the zeros of the polynomial and how to verify whether the numbers are zero of the polynomial or not. Now in today's lecture, we are going to learn two new topics, that is remainder theorem and the second one is factor theorem. Right. Now again, today we are going to learn about remainder theorem and factor theorem. If you have learned that find the zeros of the polynomial properly, then you will be able to understand both the theorem. Right. Let's start with the first one, that is remainder theorem. Now suppose p of x is any polynomial with degree greater or equal to 1, right? And let a is a real number. Right. For remainder theorem, suppose p of x is a polynomial with degree greater or equal to 1. That means it should not be a constant term, right? And let a is a real number. Then if p of x is divided by the linear polynomial x minus a, then the remainder is p of a. Right. Again I will repeat the remainder theorem. What is it? So for this theorem you need any polynomial which is having the degree greater or equal to 1. Why degree greater or equal to 1? Can be 1, right? When it is 1, that time it is a linear polynomial, but it should not be 0. Why? Because when the degree of the polynomial is 0, then it becomes constant term or else 0 polynomial, right? So here I have taken, suppose p of x is a polynomial with degree greater or equal to 1. Let a is any real number, right? Now if p of x, that is a polynomial, is divided by the linear polynomial x minus a, then the remainder will be p of a, right? This is a remainder theorem. Again, p of x is any polynomial with degree greater or equal to 1 and a is any real number. Now suppose this p of x is divided by any linear polynomial x minus a, then the remainder is p of a. That means the remainder will be p of a. Now what is p of a? It is the value of the polynomial at a, right? Now I will give one example for this so that you can understand. For example, find the remainder when x raised to 4 plus x cube minus 2x square plus x plus 1 is divided by x minus 1, right? You have given one polynomial and you have to find that what will be the remainder when it is divided by x minus 1. Now according to this remainder theorem, compare this remainder theorem and this question, right? Now this is polynomial, that is our p of x, right? Now it is divided by any linear polynomial, that means x minus a. Here we have to divide by x minus 1, which is a linear polynomial. Now that time the remainder will be p of a, right? That means for this sum, what will be the remainder? Remainder will be p of this 1, right? So to check this, we will first start with this, that is that x minus 1 is equal to 0. Therefore, x is equal to 1. Now for this x is equal to 1, we have to find the value of this polynomial. That means p of 1 is equal to 1 raised to 4 plus 1 raised to 3 minus 2 into 1 raised to 2 plus 1 plus 1, right? 1 raised to 4, that is 1, plus 1 raised to 3, that is 1, minus 1 raised to 2, that is 1 into 2, 2, plus 1 plus 1, 2, right, is equal to 1 plus 1, 2, minus 2 plus 2. So both will be cancelled. So 2 is the answer. That means when you are dividing this polynomial with x minus 1, that time your remainder is 2, right? So by the remainder theorem, when the polynomial is divided by x minus 1, the remainder is 2, right? Now let's take one more example for the same theorem. Find the remainder when 2x plus 4 is divided by x minus 1 by 2, right? Now see this. Find the remainder when 2x plus 4, that is, this is our this is our polynomial, right, is divided by x minus 1 by 2. So what we will do, we will take x minus 1 by 2 equal to 0. Therefore, x is equal to 1 by 2, right? Now for this x is equal to 1 by 2, we have to find the value of the polynomial. Therefore, p of x is equal to 2x plus 4. Therefore, p of 1 by 2 is equal to 2 into 1 by 2 plus 4. 2 will be cut. So, 1 plus 4. What is the answer? 5. Right? What does it mean? It means when you are dividing 2x plus 4 by x minus 1 by 2, that time the remainder will be 5. Right? According to the remainder theorem, when any polynomial is divided by linear polynomial, that time what will be the remainder? Remainder will be x is equal, p of a. Right? Now see again the remainder theorem. P of x is any polynomial with the degree greater or equal to 1, right? A is any real number. Now px, that is the polynomial. When you are dividing this polynomial with x minus a, any linear polynomial, that time p of a will be the remainder. The example, any polynomial is given, you have to divide with x minus 1. So take that x minus 1 equal to 0. So you will get x is equal to 1. Now for this x is equal to 1, find the value of this entire polynomial, that is p of 1 is equal to. So answer comes 2. That means when you are dividing this polynomial with x minus 1, that time your remainder is 2. Another example, that you have to find the remainder when you are dividing 2x plus 4 by x minus 1 by 2. So first take x minus 1 by 2 is equal to 0. So your x comes 1 by 2. Now for this 1 by 2, find the value of the polynomial. So p of 1 by 2 is equal to 2 into 1 by 2 plus 4. So 2 cancelled. So 1 plus 4, that is 5. That means when you are dividing this polynomial with x minus 1 by 2, the remainder comes 5. Right? Now we will learn our second theorem, that is the factor theorem. Right? What is it? Factor theorem. So again, let p of x is any polynomial with degree greater or equal to 1. Let a is a real number, right? Then there are two cases. The first one, x minus a is a factor of p of x if p of a equal to 0. And the second one, reverse of this, p of a is equal to 0 if x minus a is a factor of p of x, right? Again I will repeat, factor theorem. Let p of x is any polynomial is a polynomial with degree greater or equal to 1. Let a is a real number. Then two cases, both are related with each other, both are reverse. The first one, x minus a is a factor of p of x if p of a is equal to 0. And the second one, reverse of this, if p of a equal to 0, then we can say that x minus a is a factor of p of x. Now see, here in remainder theorem, we have learned to find the remainder. Now what does it mean by this factor theorem, right? If your p of a is 0, then we can say that x minus a is a factor of that polynomial. And opposite of that, if x minus a is a factor, then your p of a is equal to 0, right? Now see in this example, here our p of 1 is not 0. That means x minus 1 is not a factor of this polynomial, right? Again I will repeat, if this p of a is not equal to 0, then it is not the factor of this polynomial. Suppose this p of 1 comes 0 here, that time this x minus 1 becomes the factor of this polynomial, right? Same way for this one. If you are getting the answer, the remainder here 0, then this is the factor of this polynomial, right? That is our factor theorem, that p of x, any polynomial with degree greater or equal to 1, a is any real number, then if x minus a is a factor of p of x, then your p of a will become 0. Or if your p of a is 0, then we can say that x minus a is a factor of the given polynomial, right? Let's take one example for this, that examine or verify or check whether x plus 2 is a factor of x cubed plus 3x square plus 5x plus 6, right? Now compare this question with your factor theorem. Examine whether x minus 2 is a factor of this polynomial. That means we can say that x plus 2 is a factor of this polynomial when for this p of minus 2 comes 0, right? So we will take that, suppose x plus 2 equal to 0, therefore x is equal to minus 2. Now for this minus 2, if this entire answer comes 0, then we can say that yes, x plus 2 is a factor of this polynomial, right? So we will find p of minus 2 is equal to minus 2 raised to 3 plus 3 into minus 2 raised to 2 plus 5 into minus 2 plus 6. So minus sign raised to odd number, that means answer will be minus. Now 2 raised to 3, that is 2 2s are 4 2s are 8 plus 3 into minus raised to even number, that means answer will be plus. Now 2 raised to 2, that is 2 2s are 4, plus minus minus 5 2s are 10 plus 6. Now here minus 8 plus 4 3s are 12. Now minus plus minus 10 minus 6 4, sign of bigger number, that is minus, is equal to minus plus minus 12 minus 8 4, sign of bigger number, that is plus, minus 4. So 4 minus 4 0. Now see, the remainder comes 0, that is p of minus 2 is 0. Therefore x plus 2 is a factor of this polynomial. Therefore x plus 2 is a factor of p of x, that is x cube plus 3x square plus 5x plus 6, right? Now let's take one more example, that find the value of k if x minus 1 is a factor of 4x cube plus 3x square minus 4x plus k. Right, now again I will repeat that find the value of k if x minus 1 is a factor of this polynomial. Now when you have given that any linear polynomial or as any polynomial is a factor, that time what you have to do? You have to do that x minus 1 is a factor of p of x. Therefore x minus 1 equal to 0. Therefore x is equal to 1. Now for this one, the entire value of this polynomial will be 0, right? Therefore p of 1 is equal to 4x cube plus 3x square minus 4x plus k. This will be 0. So we will write 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k equal to 0. So 4 into 1 cube, that is 1, plus 3 into 1 square, that is 1, minus 4 ones are 4 plus k equal to 0. So 4 ones are 4 plus 3 ones are 3 minus 4 plus k equal to 0. So plus 4 minus 4 cancelled. So 3 plus k equal to 0. Now we want to find the value of k. So 3 will go that other side, that is minus 3. Right. So based on the factor theorem, there are two types of sum. The first one, in which you have to check whether the given linear polynomial is a factor of the given polynomial or not. For that, what you have to do? You have to take that x plus 2 equal to 0. So from that find out x is equal to minus 2. Now for that minus 2, the entire value of this polynomial should be 0. If it comes 0, that means this is the factor of this polynomial. If it is not 0, that means this is not the factor of this polynomial. Right? See the factor theorem. P of x is any polynomial with the degree greater or equal to 1. A is any real number. Then x minus a is a factor of p of x if p of a is 0. And reverse of this. If p of a is 0, then x minus a is a factor of p of x. Right? Now based on that, one more sum, that find the value of k if x minus a is a factor of 4x cube plus 3x square minus 4x plus k. Now see, x minus 1 is already a factor. That means x minus 1 is equal to 0, so x is equal to 1. So for this one, the entire value will become 0. So we will take that p of 1 is equal to 4x cube plus 3x square minus 4x plus k equal to 0. So in place of x, write 1. So 4, 1 cube plus 3 into 1 square minus 4 into 1 plus k equal to 0. Now simplify this entire. So at the end you will get the answer of k, that is k is equal to minus 3. Right. So today we have learned two things, two theorems. First is remainder theorem, right, and the second one is factor theorem. Right. Now based on this you will get few sums that you have to solve. Right.